Okay, so welcome to the, in fact, very first installation of Laura's Loquacious live stream with, naturally, my very first guest, Andy Piper. Thank you so much, Andy, for joining me today and for putting up with any potential "I've never done this before" type vibes.
Thank you so much. Hi, I'm really pleased to meet you, and thank you for making contact and asking me to come on. I'm super honored to be your first guest and the conversation you're having in this space. So I also may flounder at times, so bear with me as well if as we're going through a conversation or I'm trying to show you something, I'm not pointing at the right thing or showing you the right screen at the right time, but we'll work it out.
Yeah, that's that live stream life.
Exactly. It's exciting.
So please tell us about your background.
Yes, my name is Andy, and I live in the UK. I'm in West London right now. It's just got dark outside. It's just after 5 p.m. here. And I have a major or degree in history from back in the late 90s. But I've always loved technology. I've always loved computers. I'm totally self-taught in tech. Back in the day, I had an 8-bit. It was called an Acorn Electron, which was similar, I suppose, in some ways to a Commodore 64 or something else that you might have seen over in the US around that same time in the 80s, 90s. One of those keyboard-based computers that you plugged into your parents' TV and you had a cassette recorder and you loaded games or software off of cassette tape. Anyway, I've always been really interested in tinkering, and after university, I got a job with the UK Post Office in their IT division. And I ended up helping them with the Y2K problem, which lots of people now haven't heard of. But back in the year 2000, there was a fear just in the sort of 5 years running up to it that a lot of software that had been written in the mid 20th century. It's weird to talk about the 20th century as being in the past for me, even though we're 20 years into the new one. A lot of software was written with the dates, with the year digits as 2 digits. So 87, 88, 89. And so the programmers hadn't always assumed that there'd be need to tick over into the 2000. And so if you were going to go to the beginning of the century again, your date would suddenly go from 99 to 00, and the system might think that everything was back to 1900, not 2000.
Right.
We had a lot of work to do back then to validate that systems were going to work and weren't going to break when the thing ticked over. So if you can imagine, post office, postal system, pretty critical infrastructure for a country to be able to send stuff around. So we did a ton of work. I did a lot of work back then learning things like Unix and validating systems. Then I joined IBM, and I was a consultant for IBM for 10 years. And during that time, I was doing a lot of integration with banking systems and other things that IBM customers are interested in. But I also started to get interested in this, what we now call the Internet of Things. So this was sort of in the mid 2000s, 2006, 7, 8.
Oh, that's quite early.
It's early. And one of my friends over there, Dr. Andy Stanford Clark, he had invented back in 1999 a really lightweight messaging technology called MQTT, which was really good for sending messages and data on unreliable networks. So you might have had a pipeline in the middle of Alaska or something, and maybe at that time you didn't have 5G everywhere. You didn't have like high-speed internet everywhere, and those sensors were just these very small devices, and you wanted to be able to get data off them, and so you needed to use a little bit of network that you had really efficiently. So Andy and a colleague of his had invented this thing called MQTT. I became interested in that. And then IBM made it open source. I was already interested in open source, but that was a natural sort of move for me into sort of working with developer community, doing some kind of what we now call developer relations, but it wasn't given that title in my job at the time.
Sure.
So I've been working with dev community.
I just want to highlight Homie Coder's comment. Yes, I've heard that. I was around, but I was a smidge young to know why I heard about Y2K and that people were worried about it, but I did not particularly understand why people were worried about it. But now I
I
totally get it.
Well, it's one of those things that having lived it
Mm-hmm.
and been aware of it at the time, I'm now meeting people that haven't been aware that it was a thing. And that's kind of a mind shift for me to have to sort of go back and explain. And yeah, I mean, it passed with a whimper, not a bang, in the sense that
Mm-hmm.
things did continue to work. But thanks, homie coder. That's it's cool to know that you made you laughed about it as well. It's it's a bit of a fun background from my perspective. It was really my introduction to sort of tech as in the professional tech industry. Before that, I'd been a
Mm-hmm.
hobbyist. I learned a lot from some very experienced folks back at the beginning of my career from then.
Mm-hmm.
So yeah. So around the time I was doing the MQTT stuff, I was also very interested in something that Laura, you mentioned before we came on, before we went live, which is Arduino and small electronics and helping younger folks to learn how technology works. So we've got
Mm-hmm.
these incredible smart devices today, but if you give them to a small child, quite often, it's a magical sheet of glass, or now increasingly it's a magical voice that you talk to get information.
Mm-hmm.
No, necessarily, back when I was learning originally, we didn't have high-speed internet. We had dial-up internet. I kind of learned sort of a lot more low level how things fitted together. So I've always been interested in that part of it. And
Mm-hmm.
Arduino was really interesting to me because it's quite a straightforward coding language. You can have these little boards. I'm looking to my side. I don't have an Arduino board with me right now, but I've got some boards here, and there's this sort of similar size to what you would have as an Arduino board. This one's not an Arduino.
Mm-hmm.
That you could code for and start to connect the physical world.
Mm-hmm.
So I've always been interested in all of those things. And then I took a break, or just spent some hobby time on that, but went and did other things in my career. So I've been doing developer relations around APIs on the web for the last 10 years in different places. But most recently, I thought at the beginning of this year, I really want to have a fresh start, do something new, learn some new things in my life, and interact with some new communities. So I started to get really interested in this thing called MicroPython because I
Mm-hmm.
like writing code in Python,
Mm-hmm.
and started to get to know that community. So um, I am a hobbyist still. I'm a learner still. I'm not an expert in any of these things. I'm self-taught in all of this.
Mm-hmm.
And I think you saw me post about MicroPython and said, "Oh, that's interesting to me because you do WebAssembly and you like Python, and there's some
Mm-hmm.
crossover there that we can talk about."
Yep.
But yeah, I mean, what I do, who I am, what I do, I've kind of just told you. That's me, really. I live on
Mm-hmm.
the internet. I love to code and contribute to open source and interact with other people.
Mm-hmm.
And I love to build things.
Yeah. Yeah. And I'm sensing that you are potentially also a fellow recreational learner
Yes.
and recreational researcher, which
Yeah.
certainly resonates with me. I have ADHD, and so that's sort of a feature for
Mhm.
neurodivergent folks of always needing to learn something new.
Yes.
So for anyone who isn't familiar with my background, I am a technical writer now. I was at this time a year ago, I was still a math professor, and thinking I was going to be a data scientist, and then that took a little turn, and I became a technical writer instead because I just enjoy the teaching too much to not do it anymore. And I work for a company called Suborbital Software Systems, and we are working in the extensibility space in the WebAssembly space, so a nested space there. And we eventually will be supporting Python for our product, and I'm hoping to be on the hype team for that. And so I would love to learn more about a Python runtimes that can run in a WebAssembly runtime. So, and I also, so professionally, that's my interest. And then personally, I have an interest in more of maybe getting into IoT type side, fun personal projects.
Type side. So that's really cool. I will sort of couch the conversation in on the WebAssembly piece, especially because that's really new. So PyScript, which we'll talk about, is really new, and it's not something I know tons about. I know way for thin amounts, but we can talk about how it's sort of emerging into that space at the moment. So please don't assume that I'm here to give you the sort of the chapter and verse on that topic. There's some much more learned people in the community that can help, but we can definitely talk about sort of the broader conversation about MicroPython, how it came about, and things like that. I'm looking forward to doing so, in fact. So where should we start? I mean, how do you want to run your show here today? Because it's your first one and it's my first time talking with you.
Yes. Let's start with the MicroPython WebAssembly intersection.
Okay.
Please.
All right. So we're kind of working backwards to some extent here.
Oh, okay.
Well, so the intersection, so WebAssembly and PyScript. So beginning of this year at PyCon, in fact, I think it was March or April.
It was March, yeah.
Yeah. So PyScript was sort of formally announced as a thing, and I believe the company behind it is Anaconda. Certainly, they're the ones that have been talking the most about it and have most recently talked about pyodide, is it, or pyode?
I intuited that it would rhyme with iodide, so to me it's pyodide.
Iodide,
but possibly not.
I wasn't at PyCon myself, and I didn't watch all of that presentation. So yeah, pyodide sounds perfect. I'm happy with that. So the idea here was the ability to bring Python applications to the browser. And in order to do that, so the browsers have obviously got a JavaScript runtime sort of baked into them, but in order to bring a Python environment there, you're going to need a Python runtime. So they were showing pyodide back earlier in the year, and now they are showcasing bringing MicroPython to the same environment. So MicroPython was originally invented 9 years ago by a chap called Damien George, who's a scientist who is over in Australia, and he ran a Kickstarter. So he had an idea that it would be really cool if you could run and code for small devices in Python, because Python is an easy to learn, very expressive language. You can quite quickly sketch out an end-to-end idea in Python code. Compared to something like, if you're going to work on a very small device, you might be working in assembler or C or C++, and if you know those languages, you're going to be very, very efficient, but they probably going to take a bit longer to write effective coding, because you're having to do a lot more thinking around the edges. And so he wanted to see how small he could get a Python interpreter down to. And I think the original version, they've got it down to more like 32K or something like that now, if I remember rightly, or maybe 16K of memory on a machine. And there are some other things. In fact, I just saw a post about it today that go even smaller than that are Python-like. But MicroPython is designed to run on these small embedded devices. So there's a range of different microcontrollers that it will target. And because it runs in small memory, it also makes it ideal as a target and a runtime for Python in the browser, because you can effectively download the entire virtual machine for MicroPython and run it. I think it says in the most recent Anaconda post here about PyScript, the total size of 303 kilobytes. So really, really fast, small to download, starts executing MicroPython logic in less than 100 milliseconds. So really, there's no appreciable delay in terms of running code there. And that's all powered by WebAssembly. So the ability to bring that code into the browser and run it there.
Yeah. When I was researching shortly after PyCon, because PyCon happened in March, I started working for a WebAssembly company on the 22nd of February
Oh, wow.
and knew nothing about WebAssembly. And so this was just a few weeks into my WebAssembly journey. And so I thought that these original efforts were more to bring Python into WebAssembly, but that in fact there was the intermediary step of bringing
Right.
Python into the browser,
Right.
and then into WebAssembly,
Right.
and that it took me a second to figure out that that's what was happening.
Yeah, you had a dual layer of learning there in the brand new stuff you
Oh, I
started
think
to
my
go into.
video froze. Oh, that's
I
better.
did for a moment, but you're fine.
Good.
Yeah. So as I say, that part of it is quite new to me. Let me see if I can show you what was most recently posted about this, but I'm not going to be able to do a huge amount with it. Can I only share my whole screen? So again, I'm going to see what happens. I want to do this. I want to.
I believe you can share a window.
Yeah, you know what though? This is going to be a bit tricky. I'm going to have to send you a link because it's going to want me to restart Google Chrome, I think.
Probably.
No. Let me just approve this anyway, but I'm not going to restart it. Let's do it later. Let's come back over here. You see, this is where I should have done my preparation better.
It's so easy to forget that we have to do that. Happens to me
I just
all the
upgraded
time.
recently to the new version of the Mac operating system as well. So I need to go and redo all my permissions probably. So on the PyScript site, there is a technical preview for MicroPython right now. And it gives you some examples there. So this was mentioned in Anaconda's most recent blog post, which I will also share with you. Oh, you've done that already to the group in the chat.
Would you like me to share my screen or just the link?
If you can share the screen, then we can have a quick
Absolutely.
look through this. And that should drop us into the About tab. I might have to ask you to click in different places to come to
Sure.
go with you.
There we go. Inception for a moment. Apologies. Come on. There we go.
Okay, excellent. And of course, I'm getting confused because I'm using dark mode on my computer, but that's absolutely fine. I'm just so this is just the about page for the MicroPython technical preview for PyScript. So what you've got is the ability to run Python in the browser, and when you're doing it in this particular instance, it's going to be using MicroPython as the runtime, as the interpreter. So as it shows you here at the top, it gives you an example of what it would look like. So py-script is the HTML tag. So script is the JavaScript tag to indicate that you want to run some JavaScript in the browser. But above that here, you've got the ability to define something in Python. And I think Python itself as a language is relatively expressive and straightforward. And generally speaking, it's quite linear in the way that you read it. So this is going to define a function called hello and gives you an optional name that you can pass into it. And then it's going to return hello name from PyScript. And then after that, we simply print it. Now, if we'd like to see that executed, we can go across to the simple tab at the top there, Laura, in the middle one. And that will run exactly that same thing. So that has run that same code. And in fact, it's also printed out here, the MicroPython runtime version. So that's the current 1.19 3.1 is the current runtime version for MicroPython. You'll see on the left-hand side, though, and this is something we should talk about, it says 3.4.0.
Mm-hmm.
That's the Python version. Now, for those following at home, Python has just released version 3.11.
That's what I was
And is
thinking.
working on Python 3.12. So the other thing to think about with MicroPython is that MicroPython is based on Python 3.4.
Mm-hmm.
It has a few features from 3.5, 3.6. So Damien and the team tend to focus on the individual PEP enhancements each release to see which ones make sense to bring into MicroPython and which ones can be accommodated in MicroPython, because we don't have a ton of memory to work with. So you'll find that there are some differences between Python and MicroPython and full CPython. And one of them is that you're going to be working with, broadly speaking, a smaller range of features than you have in mainline Python.
Okay.
So
that makes sense. I was
oh no, that's a good one to be in as well. So if you go to stay on that tab, but please carry on with whatever you were going to ask.
Where were we before? I'll come back to this tab.
Okay.
I just wanted to see. I was quite surprised that the way that this works, at least what I'm interpreting, is that we're wrapping this in HTML, or the Python is wrapped. What is the order here? I would say it's wrapping in HTML.
Yeah, so you're wanting to run it in the browser. So HTML is the markup language that tells the browser what to display. So that's right. Now, again, this is all brand new. So if you're going to start getting down too far, then I'm going to rapidly run out of knowledge on this piece of how everything fits together to run in the browser. WASM itself is something that I'm less familiar with. I'm more comfortable talking about the hardware pieces, and even then I'm barely comfortable talking about that.
Yeah, but that was surprising to me. It ought not to have been, but one of those, like, well, of course, now that I think about it, of course it's getting wrapped in HTML. But when I first saw it, I was like, hey, wait, that's what's happening?
So back on that examples page, you've literally got the ability to run that hello code. And again, it will give you what you just saw in the simple page, but on the top right there, you've got a drop down for hello, and there's some more. So you've got importing the pirate library. Talk like a pirate library there to translate it into pirate. And then you've also got some other things like a Fibonacci sequence and some stuff using NumPy. You can try out there as well.
Oh, so we actually have the NumPy library.
So one other thing to talk about with MicroPython is that Python is famous for being a batteries included language. MicroPython has a smaller number of batteries included. And again, that is because the original target is small devices. Most small devices aren't going to have the capability to run complex computations. And you're likely to need very specific code or hardware drivers for specific sensors. So if you go into the MicroPython ecosystem, there's a great website, awesome-micropython.com. If you pop over there, I see you are a user of the Arc browser, which I also enjoy. Although I'm still getting my head, getting into the habit of it's awesome-micropython.com, and this is an awesome list. If you're not familiar with awesome lists, they are awesome. Lots of different projects, environments use awesome lists now. So that's there we go again.
Sorry,
that's all right. I should have done that. I could have done that for you, since you're doing the hard work of school. I couldn't have done it for you because I'm not in the Twitch channel. But what you'll find here is that On the right hand side, you've got a list of all the different libraries that are available, and a lot of them are either for different protocols that you might be using in a Internet of Things type environment. So beyond Bluetooth and Wi-Fi, you're looking at GSM, GPS, Modbus, something very small. Modbus and CAN are used in things like automotive, but then also below that you've got I/O, you've got sensors. So you've got drivers for lots of different little tiny sensors. And within each of those sensor categories, you'll probably have 6 or 7 different types of sensor. You can usually pick these things up. And this is where I lean to my side again and look for some of the sensors I've got here. This is I've got a color sensor here that I think is an Adafruit one.
Are
You
you
can just plug
showing
in.
me? Oh, let me just stop
You're
sharing
not
for a
doing it
moment.
because you're looking at and I'm holding this too close to my camera. But what I can do, I think, is switch across to my other camera and we can look at some boards if you'd like.
Fun, yes.
Now, we talked about this beforehand, and I'm going to have to switch my camera to here. So, and now I'm going to try and split my attention. But before I do that, I just want to quickly send this toot to tell people we're here. So I've got a range of different boards here, including one here that's lit up right now, which is I'm not able to. This one, it actually is it's got a load of LEDs on it, and they're white. So that's using a project called Cheer Lights, which was set up to synchronize light colors around the world. So you can tweet to Cheer Lights and just say Cheer Lights blue, and then it will change the topic, the hashtag or the MQTT topic, and then anything listening to that topic would pick that up, and the color of everybody's lights would change. So I've just moved that one off the camera because it's quite bright.
Oh, I love that though.
Turned it down. This one is it looks like a single light, but it's actually a grid of 25 LEDs on there. And there are RGB LEDs, which you can which it modifies depending on the color. Actually, I think that one, believe it or not, it looks white on the camera, but this one is meant to be something like light pink at the moment because I'm looking at another light in my room which is also listening to Cheer Lights, and they look more pink than that one does. So that's light the camera. You can also see this big grid at the back here. This is a device from a company called Pimoroni. They're based in the UK and they make a lot of gadgets and things for the Raspberry Pi ecosystem. So they started out building hats for the Raspberry Pi, and now they make a lot of stuff in that same space. So that's a grid of I can't remember how many LEDs are on here, ridiculous number. But if I run some MicroPython code I've got here whilst we're talking, it will do something a bit more interesting, hopefully. So I'm just clicking run in my IDE, and it's now going to scroll across and say MicroPython and do some other things while we're talking. So yeah, I'm thinking that I might have to rejoin our chat in a minute, and otherwise I'm not going to be able to share my screen, am I, and show you some of the code.
I mean, feel free. It's very quick.
Well, let's do that in a minute. Let's in the meantime, let's let this run through. So the Galactic Unicorn is using something called the Raspberry Pi Pico, and it's this one here, the Raspberry Pi Pico W. These are about $6 or $7 to buy. Now, the difference between this and a Raspberry Pi is that these things and all of these boards are microcontrollers. They're not CPUs. They are MCUs, microcontrol units, not CPUs. It's computer processing, central processing units. So they are not doing, this is now scrolling the temperature and humidity across the screen because it's got a little sensor plugged in on the back.
Nice.
So they don't have a full operating system on them, right? You're running effectively Python as close to the bare metal as you can. You don't have you do have a REPL, so the ability to run Python code interactively, but you don't have all of the other stuff the operating system might give you. You don't have a display driver, you don't have a file system. You're talking directly to the drivers, not to the operating system. So if I want to drive these LEDs, you're literally talking to the individual LEDs or the grid of LEDs. On an operating system, you might have, you know, an API to make that call.
Mm-hmm.
You're doing things at a lot smaller level. So the Raspberry Pi Pico was one that came from the Raspberry Pi Foundation. They launched the Pico at the beginning of 2021. This is the Pico W. So in fact, I've got two here. This one's a Pico built into a much bigger board. Oh. This one's called the MicroPython Pico from a company called Citron. And this one's actually built for education. You'll see it's got this label down here. The idea is that a student could write their name. So it says this MicroPython Pico belongs to, and you could write your name in there. Mm-hmm. Again, move that shear lights one out of the way. But this board, this is the original Pico. Didn't have Wi-Fi, didn't have any kind of network connectivity. But it's got all of these other things. So it's got an SD card holder on here, so you could plug in an SD card and record information to an SD card. It has a buzzer. It has an audio jack. It has an on-off switch. It's got some push buttons down here in the corner so that I could read in my Python code when I'm pressing buttons. Mm-hmm. These connectors here are called Grove connectors. So you can get devices that plug directly into those Grove connectors. It's got here an RGB LED similar to the one on the other board that I was just showing you. And that one didn't have any Wi-Fi, so that came out at the beginning. Just the board came out at the beginning of the Raspberry Pi Pico itself came out at the beginning of 2021, and then during the year, different manufacturers started to add it to different devices. And then this year, back in I think May or June, they came out with the Pico W. That's got this big metal blob on it here. So that's underneath that has got an additional Wi-Fi component. So this one can go directly onto the web, onto the internet, and run logic. I've got a load of other boards here. This one is called a Tufty 2040. This one is also based on the RP2040 chip. The RP2040 chip is the chip that the Raspberry Pi Foundation have on the Pico. Oh. So the Tufty 2040 is again from Pimoroni, and you can see it's got this space here for putting a lanyard, because this is like a conference badge.
Oh, fun!
But that's one they came out with. Before they came out with this one, they came out with this one. This one is called the Badger 2040, which is even more like a conference badge, and it has an e-paper display. So this isn't currently powered. But because it's e-paper, the last piece of code I ran and is showing on here. So if this is powered,
love that.
This one is again it's got the RP2040 chip. It's a custom board, so it's not got the full green Pico on the back. This is a big blob of Velcro, by the way, so I can attach a battery pack if I need to. So ignore that. It's unfortunately covered up the lovely picture of a badger that they have on the back here, but yeah, they do some really nice silkscreen prints on their boards. Nice. This one can be connected over USB-C. It's also got another connector here for plugging in sensors. It's got some buttons. Oh, the cheer lights color just changed to red over here in the meantime. But after the e-paper one, which is obviously great because it's quite low power, generally speaking, it doesn't need to use power until you press a button or until it needs to refresh the screen.
Right.
So battery life is great. The Tufty 2040 has a color screen, so you can do a bit more. And looking around, they've also got some. I'm
curious how heavy those are. Do you know what they weigh?
Off the top of my head, I don't know. I mean, they're not. These two are both okay on a lanyard. I've used them on a lanyard, both, but I'd have to look on the website to. Sure. I don't have any scales right next to me right now. They also have a range of boards, and this is not me being doing a deliberate advert for Pimoroni, but they do boards. They do some nice ones here for environment sensing. So these ones have the full PicoW on the back. And so this one would, if I plugged it in, again, coded in MicroPython, would let me read from a range of sensors. It's got temperature, pressure, humidity, light, color. And then the kind of thing I might do with that is to publish that information to a message broker. So using something like MQTT, or I could make an HTTP call from the board to deliver the data somewhere. Or I could write the data to a file and then every now and then pick up the data. So if I was doing field logging, but the idea of these ones is that you could publish it to a message broker, and then something like HomeKit, Home Assistant, one of the in-home brokers for managing your home environment, could detect, the temperature in my study right now is 17 degrees or whatever, 17 centigrade, whatever it said on the display a moment ago when that was scrolling across. They've also got one here which has a screen on it, and I will need to unplug something in order to plug this one in because it needs a USB micro USB.
Perennial problem.
So in the meantime, I'm going to plug this guy in, the Pico Enviro, and it should start up and then tell us very, very fast. It's just literally started up and it's immediately showing us the temperature. I don't know how well we can see this on the screen.
Oh, I can see it very well. Yeah.
Is that good? Yeah. Okay, good.
What is the RH?
That is the relative humidity.
Ah, and that's bad. Why is that bad?
Well, it's what it's telling me is that it's very high in this room at the moment, but it may not have calibrated very well. And also the green bar on the side is showing you something as well. So I'm forgetting what the light sensor is. This one in the corner. So if I bring this up to the light, it says bright now, and then if I hold my finger over this sensor here, it goes dark.
Oh, neat.
Instantly. So this one's really great. Again, it has Wi-Fi. It can do all the things that the other one can do, but it has the screen as well, so I can potentially press the buttons and engage with it, switch the screen on and off, and so on. So these are really fun to code for. One other thing that I really love is that MicroPython is the core for a lot of these other Python distributions. So I mentioned Adafruit have one called CircuitPython, which is awesome and very well documented. They've got some really nice hardware in their environment as well. But it also runs on this, which is called a BBC microbit. About 5 years ago, the BBC in the UK gave out one of these to every school child in the UK. Again, this can run over micro USB. It's got this array of LEDs on the front here. They've got an in-browser editor for Python, and it's got this edge connector, so you can either plug it into add-on boards, or the reason that these are broken out like this is you can use crocodile clips to clip things on, so it's much easier for youngsters to add things to this.
I love that.
Yeah, I think it's very, very cool. Now, this has Bluetooth. It doesn't have Wi-Fi, so it can connect to your phone, and there's a phone app for engaging with it as well.
Is there something similar? I mean, that sounded like sort of a limited run item. Is there something similar?
So you can buy. So the limited run was the ones that they gave out to all the school children. You can buy them now.
Ooh.
So if you look at microbit, you will probably find that those are available. I don't know how widely available they are. They're certainly quite popular in different places where I am. But the Microbit Foundation is an educational foundation, and they have an education team that works and teaches folks to write code in Python in the browser. They also have a blocks-based editor. So if you are not wanting to immediately dive down into text-based code, then if you've ever seen something like Scratch, it's a very similar style of editor.
Nice.
So you're dragging functional blocks together. So it's really teaching you the logic of how things work. And then that is a stepping stone, or some would say it's a stepping stone into going down into the code and learning to do things by hand yourself.
Yeah.
So I
I
think,
have a 5-year-old who's just starting to learn to read,
oh
and
wow,
so he's this close to
yes,
being able to use Scratch, and I know he's going to love it. So it's very exciting. I also have 2 teenagers, and so they were using Scratch ages ago,
right,
and yeah, so we have very fond memories, and I'm sure that it's come even further in
yes, for
10
sure,
years. So
yeah, absolutely, yeah. I think that whole space is something that really inspires me. When I, again, going back to that conversation at the beginning, when I was learning computers when I was growing up, yes, they were expensive items, but
Mhm.
you could look and see and feel. And if you took the case off, you could look at all the components, as I think you could do with an Arduino. The original Arduinos were big fat chips. They weren't surface mount chips. You would plug the chip into the socket. Uh,
Mhm.
and today you've got these much smaller. Again, I'm trying to do multiple cameras when I've only got one feed to the conversation. But you've got these other devices that have much smaller chips, but they've got more expressive and physical breakout boards or ways to plug in different sensors. The other thing, actually, I'll switch back the camera very quickly, that I'm excited about with MicroPython is that it's also used in another environment called PyBricks. Now, PyBricks takes these Lego boards. Now, Lego have a range of powered devices, and typically their programming environment for these, this is from the Lego Boost kit, but there's a number of other kits. There's a Lego Star Wars Droids kit, and there's some other ones. And they give you these kind of bigger, chunkier things here. There's a big green button in the middle, which would switch it on and advertise it on Bluetooth.
Uh-huh.
Then they have these cables that are very easy to unplug and plug in. And they've also got these things down here. So these would be where you put in a Technic part or Technic axle, so you could have wheels or something. So this would be the body and brain of your Lego robot. Now, Lego have their own Python, and they have their own iPad app or Android app for coding for these things.
They have their own Python?
So Lego found a Lego group do a lot of stuff with Python as well. But PyBricks takes MicroPython and uses it as the core to replace the default Lego runtime, which these things come with. Again, if you were to buy this, then you would be pairing it via Bluetooth with your phone or tablet, and then you would be using more of a blocks-based editor to code for it, which is cool. But if you wanted to go down to do more with the code, play more with the code, then there's this distribution of MicroPython called PyBricks. It's developed out of the Netherlands, the Netherlands and the US, the two main collaborators. And they actually came, Laurel from PyBricks actually came to the last MicroPython meetup and gave a demo. So there's a video of that on YouTube of PyBricks being shown off. But it replaces the firmware on these devices, on these brains and bodies, with MicroPython, with their own build of MicroPython. So MicroPython's kind of got almost a distribution type model, like you might think of Linux. People take the core of MicroPython and do other things with it. So PyBricks being one of them, Microbit Python for the microbit being another. Broadly, it's the MicroPython core, but they've made some modifications to make it work well with the sensors and components. And then you've got CircuitPython, which takes MicroPython, really builds on MicroPython, takes it in a slightly different direction for the Adafruit audience. They started off where every device showed up as a USB drive, and you would just save a file onto that USB drive, and then it would run. Increasingly, some of the more recent boards don't always have the ability to have an actual file system. or present themselves as a USB file system. So they're moving into a web-based workflow with CircuitPython. But again, the Adafruit ecosystem is just incredible. The stuff that folks come up with. They've got excellent support for USB. So I've got something here called the dial toner. This is a device that you can plug in over USB, and it's got these 6 dials and a button on the end. So somebody built this, a chap in Canada built this, and there we go. Camera, come on, focus on the border, not on me. Failing. RGB under each of the 2 pairs of dials, or 3 pairs of dials. So you can dial in a color in hex on this. It will change the light, it change the LED color under the button to the color. Then you press the button, and it sends it as a keyboard command to the computer, and it will paste in the hex code. Now this is very silly. This is incredibly silly, but it's super cool. I love it. I love it. It's tactile, fun. This is written in CircuitPython. So the code for this is in CircuitPython, because CircuitPython has a really good support for pretending to be a USB keyboard or pretending to be a USB something else, which is just going to work with your with your computer. Now that was quite fun, because I discovered, I think I was the first person in the UK to get one of those. So when it arrived, it was putting and I was pressing the button, it was pasting it in, but it had a British sterling pound sign at the beginning instead of a
right.
Because that's where our keys, that's where what our typical UK keyboard would have a currency sign instead of the hash symbol. So he had to rewrite the code with a special British option for British keyboard users.
That's interesting. So our currently in the US, the currency sign is on what, the 4, and the hash pound sign is on the 3. So what's on your 4 then?
It's the same. We've got the dollar sign. Well, having said that, I'm looking at my keyboard here, which is a US layout, or it's got a US layout on it at the moment. Yeah, it varies where it is, but normally it's an Alt. So Shift 3 is the UK currency symbol, and Alt 3 is the pound sign, is the hash sign, or the other way around.
Okay.
So it varies.
What's on the 4?
The dollar sign.
Oh.
Yeah.
Okay.
Because everybody uses dollars everywhere, right?
I see. I guess I would have intuited that you'd swap out the pound sign and the dollar sign.
I mean, yeah.
the GBP for the USD.
I can't explain the vagaries of keyboard layouts and why Britain and America use different measurement and currency systems. But hey, so something else that you can look at if you're interested in MicroPython is there's a website called Wokwi, WOKWI.
Drop that in the chat here.
And this is really neat. So PyScript in the browser lets you start playing with MicroPython without having to have all of this hardware that I've just shown you. And by the way, a lot of those boards are super affordable. Those are starting from a few dollars. The more sensors and gadgets and Wi-Fi and things they add on, the prices do go up. But a couple of those boards are really super affordable. They just get more expensive when you start to add in all the sensors and all the other things you might want to connect to, and especially if you want to do anything mechanical and how you have servos, or you need your own battery and power charging circuits and things like that. E-paper displays are still quite expensive and so on. So anyway, if you don't want to develop a massive hardware habit like me, you can use Wokwi. Now, Wokwi is really cool because, as you'll see, it's a simulator, and they simulate and pretend to be different chips. So you've gone right there into an Arduino, and an Arduino Uno, that's the original Arduino, or one of the original sort of Arduino style boards, and that's running an 8-bit microcontroller there, the Atmel chip, that big chip at the bottom right of the board. And that code, as you can see, is is C++ or C style code. Now, if so joystick etch a sketch line, you've clicked run. So now if you were to go and move that joystick around with your mouse, so that big round bit above the board, you can, in principle, you'll start to draw a line, and you'll see there's a red dot coming out. There you go. So you've got an etch a sketch going on that little LED display. So that code is exactly, assuming you were to wire up you had those components in real life, and you were to wire those things up in the same way and run that code, that would be exactly what you'd be looking at.
Oh, that is so cool.
Really, really neat. It's an incredibly clever simulator. But if you go back to the previous page, you'll see, and scroll down further down the page, we'll find a MicroPython one. Just under the power votes, there is a MicroPython MQTT weather logger. So that's one there. So if you were to, I need to remember how this one works, or have to look at the code to see how this one works. So this one wants to emit a MicroPython, sorry, an MQTT message. So the first thing it does in the code, after it imports all the libraries it needs, there's an important one, by the way, here in MicroPython called machine, which is the line 22, the third one down, because that's going to let Python talk to the hardware, the physical hardware, and get inputs and so on from the hardware. But if you carry on down, so let's just talk through the code. We're importing network, which is going to allow us to connect to the Wi-Fi in a minute. We're importing the pin from the machine. We're importing DHT, which is the temperature and humidity sensor. If you look on the right-hand side, that white thing, DHT22, that's quite a common temperature and humidity sensor. So that DHT is a library for that. And then we're importing micro-JSON or UJSON. So by convention, the MicroPython version of these libraries puts a U, like a micro U, in front of things. So if you think about mathematical notation, if something is micro, you have a little U or mu symbol on the
mu.
There's actually a MicroPython editor, a Python editor called Mu by Nicholas Tullivery, who's also the person who's working on MicroPython in PyScript at the moment. Anyway,
small world.
Let's carry on down this bit of code. We're going to set up some variables which are going to set up the broker, the MQTT broker to talk to, which is mqttdashboard.com. And we're going to set a topic of WACWE weather. So that's going to be the label that we are going to publish our weather information on. Then we go down and we set up our sensor. So it's saying our sensor is a DHT22 temperature sensor on pin 15. So on the right-hand side, if you were to hover over the green one, the top one, there we go. You'll see that it connects to digital pin 15, D15. The other two cables are the power, so ground and 3.3 volt.
Gotcha.
Okay, so we're connecting with this board on the right hand side is an ESP32. I'll tell you a bit more about that in a second. So it's a microcontroller called an ESP32. It's got a ton of pins. You can see them along the holes for them along the side. Physically, you would be connecting over that USB micro USB port at the bottom. It's got a couple of buttons there. One of them is a reset button. But in order to do anything, you're going to need to connect it to some sensors, and to do anything other than connect it to the internet, you're going to need to connect to some sensors. And this sensor, that would typically be about the size of the end of your thumb, that DHT22, a bit of little plastic sensor. And it's got these 4 pins. And we are reading off of the digital 15. Some sensors are analog, so you're going to, so you're not just getting 0 or 1s. You're getting, you're able to do things like ranges more easily. So that's another difference. So when you get into MicroPython, especially with hardware, you start to learn a ton more about how the electronics and the hardware works, and how things talk to the computer. All right, so carrying on down our code, back over again. We're going to connect up to the Wi-Fi. So that would assume that we'd given it Wi-Fi credentials. Now, in this case, because we're running in the browser and we're running a simulator, it's just going to connect. Okay, it's going to become online. In my case, if I'm running something at home, when I give it the network and this STA bit, I would be giving it, or the connect, I would be giving it my Wi-Fi user SSID instead of what we guessed and my password.
Sure.
And we print out that we're connected. We connect up to the MQTT broker, giving it all the information we had earlier. And then it says it's measuring weather conditions. What it's going to do actually is measure the temperature and humidity from our virtual sensor. Now, if you click run over on the start side for this one, and then you click on the white sensor, you'll get a slider at the top. And this is going to let you specify your virtual temperature or humidity of your sensor. So again, bearing in mind, I showed you both on the Pico Enviro when the screen, when it had those numbers on here on my board, and then also on that scrolling LED display I had earlier. Those both weren't using a DHT22, they were using an AHT20, which is an analog version of the same sensor in a package. But as they were doing something very similar. They were reading in MicroPython the current information and putting it on the screen or the display. In this case, it's every time you scroll across the top there, only when it changes, it's going to publish a new message in JSON format on an MQTT topic to that WOCWI topic on the MQTT dashboard broker. Now, anybody now on the internet who wants to can go and subscribe to that WOCWI topic on that MQTT dashboard because it's a public broker and would be seeing those data values come in from your virtual sensor.
Oh, neat.
Typically, what you'd want to do is not have it called WOCWI, whether you'd want it to be specific to your device. So what I've often done is I've done something like get the MAC address of the Wi-Fi chip so that it's unique. Included that in the topic. And then obviously include my name. So those topics, if you're not familiar with MQTT or publish and subscribe, those topics can be multi-level. So you might have, if you think of a tree of information, you might have device at the top of your tree, which would have a unique name. And then under that, you might have temperature, light, and something else. And each one of those could be separate values. Or you could have a house. The house is probably a better example, because I've got gadgets in different rooms that are measuring sensor and light levels and noise levels in some cases. So each of those rooms might want its own topic. My house might want to be the top of the tree. So I subscribe to Andy's house bedroom. And then when I'm listening on Andy's house bedroom, it will be getting all of the data related to the temperature and humidity in the bedroom, for example.
Is there a limit to how many times you can nest?
Technically, I believe there is, and I can't remember it off the top of my head. It's to do with the length. So MQTT, as a messaging protocol, is an OASIS standard. So it's all documented. I don't remember what those are plain text topic names, and then there's a slash between them, and you can have wildcards in that tree. So you could say, let's say you've got Andy at the top of the tree, and then you've got car and house as the objects, and then inside the car you might have elements of the engine, and inside the house you might have rooms. If you could subscribe to Andy / hash or £, and that would say give me everything that Andy owns. Or you could say, give me Andy / car / £, give me everything about Andy's car. It gets, you can format these things to whatever level you like. A lot of different devices are possibly ones that you use if you've got any sort of smart home devices are already using MQTT, because it's this very effective protocol. You're only needing to publish updates when things change, not all the time, so they can be quite effective from a power perspective as well. It's not the only way to do things. You can have HTTP calls made. You could be logging data locally if your chips don't have Wi-Fi and so on. I said I was going to briefly talk about that ESP32 thing you had on the screen a moment ago.
Oh, yes, just a
Um,
moment.
all I will say there really though is that there are a range of different manufacturers and vendors of silicon chips, right?
Okay,
So that's it. So, I mean, just for the sake of comparison, I showed you some boards on my physically earlier. And again, let's just pick one up to hold it up to the camera for those of you that can see that whilst Laura's got the screen share up. So this is a Pico. This has got an RP 2040 chip on it, which has a certain number of IOs. So, I've frozen now for some reason, I think. Sorry about that. Let me try.
I think maybe we've lost Andy for just a moment. Yeah. No worries. Oh. Hello.
Hello. Can you hear me?
Yes.
That's a relief. So I've switched to my other camera because the one that's pointing at my face is not suddenly decided not to play with me anymore.
Oh.
But you can still hear me. I can
Yes.
put my hands down here. It's me. I'm still here. I promise. Sorry for that.
No, not at all.
So each of these chips has a certain number of IOs, inputs, outputs. And they have different capabilities. So the RP2040 is one here from the Raspberry Pi Foundation. The ESP32, which we were looking at in the other example, is from a company called Espressif. And they have a range of different models of ESP32 that run at different speeds, that have different levels of input-output, some of which support Wi-Fi and Bluetooth, some of which just support Wi-Fi, some of which don't have have different levels of analog and digital inputs. There are a number of other manufacturers. So if you go to micropython.org, then go to. I don't have an answer for that. Excuse me, Siri. I didn't ask you anything. And go over to the download tab on micropython.org. Then it's a bit of a busy page, but you'll see it says filter by port. So across there are different types of chip. So you've got STM32, you've got SAMD, RP2, which is the RP2040, ESP32. And then below that, as you click on each of those, it will filter down to the boards that have that kind of chip that are supported. So each of those different chips has a different compiler, if you're coming at it from a machine code perspective, each of those different manufacturers comes up with their own chips, their own silicon, they have their own SDK, they have their own C compilers. MicroPython takes away some of that complexity because as long as you have the right port, so MicroPython is built for the right chip, then you can still write your code in Python or MicroPython, right? So I can run, very broadly speaking, very similar, if not identical, MicroPython code on an ESP32 board as I could on an RP2040 board. Capabilities will be different, so I have to be a bit careful. It's not 100% just copy and paste onto the other board, but very broadly speaking, that would be true.
Very handy.
Which is what another reason why MicroPython is extremely cool. With quite little effort, you can modify to run on a different type of chip. You need a different runtime, so that's what that download page is. So that will download a little binary. There's instructions on how to copy it onto your board and enable it to start running. I'm going to just give my other camera another go. It's decided, no, it's definitely still not happy with me. Sorry for that.
No worries
I think it's because I've got too many USB devices plugged into my computer right now, and it's not wanting to have fun.
Mm-hmm.
Oh, hello. That's working. And now my browser doesn't want to work. Let's go back to the other one. What a shame.
Computers, man.
Yeah, who'd play with computers? Sorry, I'm now just a talking circle, which is entertaining.
Yes, I love the animation.
Start camera. No, that's the wrong camera.
Yay.
Well, there. Oh.
Hello, it's you.
So yeah, that's been a lot of talking and a lot of blathering, really, about things.
It's been a wonderful tour of the
I'm glad to.
MicroPython ecosystem.
What else can I tell you about? There's just like with any other Python environment, there are a range of options for where you write your code. So we've looked at a few things that run in the browser, but typically, especially if you're using hardware, you're going to need to write code on a computer and get it onto a piece of hardware.
Sure.
So there are a number of IDEs. You can use a text editor. You can use Vi or Vim or Emacs at the command line if you want to, and there are some tools for copying your Python code onto your hardware device. Of course, with PyScript, it would be being delivered through the browser, but you'd still need to be able to put it on your server to have the browser pick it up. There are a couple of really good IDEs. There's one that I use called Thonny, Thonny, and there is another one called Mu, MU, which is by Nicholas and his team. They just literally this afternoon came out with a new version. I haven't had a look at yet, but that's got some really nice. That one's got a mode-based interface, so it simplifies things if you're working with a Raspberry Pi, for example, or some of the specific devices. It's got very good support for CircuitPython as well.
Okay.
You can also get plugins for Visual Studio Code. You can get your own. There's PyCharm, which is a Python IDE, which has a MicroPython plugin. So it's kind of your choice in terms of where you do your coding. But with the IDEs, and typically they're going to have a little bit more tooling for working with the board, maybe installing libraries to the board, because you need a driver for a display or a sensor. They might have auto completion or nice formatting, something like that. And typically they'll have the terminal as well, so the ability to go into the REPL on the board, it's connected, and try things out interactively, which I find really useful. I think it's one of the best parts of Python as a language is you don't have to do that full compile cycle you might have to do with a language like C. You have to write the code. You might get some linting and auto assist. You still have to then compile it. The compiler might then tell you made a mistake, and then you have to get the binary onto the board or run the binary separately, and then might get a runtime error. Whereas Python, you compresses a lot of that sort of loop of execution, and also that loop of coding.
Right. Yeah. I learned Python in a Jupyter Notebook first.
Okay. Yes.
Which was very friendly. I do like an IDE. When I was coding exclusively in Python, I did use PyCharm. Now I'm more likely to be in Markdown or Go or who knows what, and so I just sort of default to VS Code since it does all the things.
Yeah, I mean, VS Code is my editor of choice today for sure. And because MicroPython has some nice command line tools, there's one called MP Remote, which ships with the latest version of MicroPython, which is essentially a CLI for managing your devices and copying code backwards and forwards from them, or listing out which ones are connected. You can script a lot of those things as well. If you want to just run a quick shortcut command in Visual Studio Code, you can do that. So yeah, I either use that or I use Thonny. Thonny also runs on Windows, Mac, and Linux, and I jump between the the different environments. One of the things I mentioned in my talk at Dublin EuroPython is though that you might well use a Jupyter notebook because you've got that ability to see stuff running. You could be learning Python from a data science perspective. It's super popular and effective there, and you've got that richness of all of the libraries like NumPy and other things that help you. It scales up very, very nicely to running on bigger and bigger systems. And the keynote at EuroPython was from one of the folks who work on the James Webb Space Telescope, and they're using Python to do a lot of the image processing for the images that come back, the data that come back, and they produce those lovely graphic images of galaxies far away. So it scales up really nicely. You might well be running Python now by default. Most folks code for cloud-based environments and horizontal scaling. It also turns out that it scales down really well, or it can scale down to these smaller devices. There are limitations. You can't do some of the things that you might be able to do by default in CPython, Python 3.11 on your computer, because you've got a fewer range of libraries. Most of them have had to be re-implemented directly in first of all in C to work within the device, and then have a Python wrapper, or rewritten in pure MicroPython to run against the runtime that they're on. So I find it fascinating. I think it's such a lovely endorsement of the way that you can take that philosophy, that syntax, all of the things that come with Python and the community and the friendliness of the community, and see it go from really small devices all the way up to something really big. So I'm enjoying it.
What would you recommend as a port into the community for those of us interested in?
Yeah, great
learning
question.
more?
Great question, because that's where I started, was trying to, when I want to learn something, particularly around an open source project, I like to try to take my time to learn about the community, the people that use it, what they're using it for, things they've been successful, finding out who are the most knowledgeable folks, and who needs help, and who could use assistance in bridging the gaps in knowledge to learn a bit more. So I started out in that exact spot at the beginning of this year. I started at micropython.org and then started clicking around. There used to be a forum hosted on micropython.org. This year they've moved it into GitHub, so now it's a much more GitHub-centric project. GitHub.com/MicroPython. You've got the MicroPython runtime. You've got the discussions there for the language and community. You've got the documentation. You've got MicroPython libs, which is all of the libraries that are part of MicroPython, but they get compiled in or added to the runtime depending on the board. So that's one great place. Another great place is that one I've shown you already, also micropython.com. Which is run by a member of, it's another project run by a member of the community. Folks submit pull requests to add their code there. And the idea is it's awesome lists. The idea is that, you're validating that something is awesome, right? This is a good piece of code. This is something that you more than me will find useful. I've tried it. It's great. It becomes that great sort of crowdsourced index to useful knowledge and information. So the GitHub discussions is great. Also, MicroPython is great, and they also have a Discord. Previously, real-time chat was kind of divided between IRC, Slack, and Discord. And in the last 6 months, the group has kind of come together and said, "Look, let's focus on Discord as the main place where we're going to go." So if you go to their Discord, which is linked from, I think. It was certainly linked from my most recent blog post on Dev at the end there. They've got different channels on there for different things. So you might have, let's just turn to the side and look here. You've got sort of stuff generally about the MicroPython language. You've got something about MP Remote, which is for their CLI. Then you've got a whole section on different hardware. So in the individual chips, so the RP2040 or the Pico, Lego and Pybricks. ESP32 we've spoken about. That's where I started. You've got drivers. So, who's built a driver for this particular sensor board that I've got? And then there's a whole section on there for WebAssembly now. So I'm guessing that's where you'll start to see, and I haven't spent any time in that channel yet. More folks talk about PyScript and using MicroPython as the runtime for PyScript in the browser. So I've found the community super friendly.
Great.
I've also found the community and I think most communities would like you to show that you've made an effort to learn a little bit, do some research rather than just come and ask for the answer straight away. Sure. So I think that, if you pop into as an example, if you were to run into the drivers channel on Discord and say, I urgently need a driver for this thing, give it to me now, people might think that was a bit rude unless you were to say, I've looked on Awesome MicroPython. I haven't seen, I've done a search on GitHub. I can't find any examples of anybody doing this. Has anybody heard of this? This is why I need this code, or this is why I'm trying to work on a driver for this. Give a bit more context, be a bit more collaborative with folks to get involved. So
my friend and coworker, Ramon Huidoboro, just wrote a blog post maybe yesterday or the day before about how to ask good questions. So I'm going to link that as well. It's all the same things that you were just saying, but in written down form.
Great. Yeah, it's not always easy, and quite often it can be very frustrating, and it can even lead you to feel panicked if you have a problem and you can't fix it, and you think you've tried things. It's always worth just sort of stepping back, writing down or thinking through what you've tried. It's almost like that rubber duck kind of testing, the thing where you've got a rubber duck on the table and you're talking through what you did. And it's kind of similar, right? If you go onto Stack Overflow or you come into a chat channel and you're able to talk through what you've tried, then even you might spot the solution to the problem more quickly. So yeah, I think that's great. I'm going to definitely check out Ramon's post, because I kind of thing.
I used to say the same to my students when I had a template for them to fill out when they were asking questions. Once we'd pivoted to remote learning, I found actually that this was one of the benefits, was that when they were filling out asking a question on our discussion board about a problem, there was a template. This is the problem that I am working on. This is a picture of what I have tried. This is why it's not working. I thought maybe these things, or I'm wondering, or I'm just complete, but more information and so on, than just what is the answer to this question.
Yeah, absolutely. So I think, as I say, I found it a friendly community, and I've really enjoyed jumping onto the MicroPython monthly meetups, which are the very beginning of my day, the very end of the day in Australia. Depending on your time zone, it may not be quite as easy to get involved, but and maybe we need to start some more online spaces or in-person meetups for this stuff. I think as the runtime broadens its audience through the browser, for example, and as well as to hardware, as well as on the hardware side, hopefully the audience will grow, and we'll generate some new places to have some fun conversations. I'm personally quite excited, and I don't know what the potential capabilities are of actually getting to a point where the crossover is not just that you can use a MicroPython runtime in PyScript in a browser and WASM and all that kind of fun stuff, but you can do something in hardware and sensors and some kind of connected device that's in MicroPython and talk to something that's presenting data to you in a web browser through MicroPython on the other side of things. So you have more end-to-end situation, but who knows where this might go.
Right.
I'm just delighted to see, similarly to MQTT, when those folks took that problem from the 1990s of low bandwidth networks and needing to be very efficient, and then finding actually that this thing they built, this low bandwidth messaging protocol, has this broad applicability in all kinds of places. MicroPython is finding, when you take something and optimize it in that way down to the basics. Now, Python 3.11 that was released recently, of course, has had a ton of amazing performance optimizations, but that's CPython, that's full fat, running bells and whistles, and that's awesome to see as well. But MicroPython is sort of focused more on the constraints of the device or the environment. And even if you come along and say, well, we need these features from Python 3.9, 3.10, or whatever they might be, or these brand new syntaxes, you might need to think more about how that fits into this philosophy of keeping things as efficient and constrained as possible.
Right. Yeah. And I know that that's something that really informs from my company's perspective. Most people, perhaps a lot of our potential customers would be data scientists, and so they would be wanting to be able to use pandas and scikit-learn and NumPy, and they want to use all the libraries. And if they can't use their libraries, this is really not very helpful to them.
Yeah.
And of course, it's all very early days.
Yes.
So it'll be interesting to see how that all plays out, being able to bring in those libraries.
I agree. I've seen people come along to the MicroPython forum and want, more complex scientific processing available, and you simply can't always squeeze all of that down into that space. Now, there is a really interesting project that came out a couple of months ago, and I'm going to struggle to remember what it was, but it basically let you hand off your MicroPython, your code on in a regular Python REPL to another device. It was on Hackaday. I'm forgetting the name of the project now. But it was super cool. Oh, it was also on the Bootloader. Have you come across the Bootloader podcast?
No.
So the Bootloader is by a Bootloader. I'm doing my research as we speak because I can't remember. Bootloader podcast.
I found it.
Paul Cutler and Todd. Todd Kurt, and so both of those are heavily involved in CircuitPython, and they do a really good podcast, not just about CircuitPython, but it is about tends to be a lot about hardware, and that's it, called Belay. The project I was looking for is called Belay, and I love the Bootloader. It's quite a stackable podcast because they have this format where each of them, I think, gets to bring 3 things each episode to just talk about and very briefly mention, and they're not allowed to spend longer than 5 minutes each talking. So it's going to be always going to be less than half hour. It's probably about 15 minutes usually, just to say this is cool. So Belay is the Python library that I'm talking about, and I'm just going to find you.
Is that belay like in rock climbing?
It's belay as in belay that order. Maybe the same kind of belay. But the idea with belay is you can be running on your desktop computer and set up and tell it about a device that's attached, and then belay or offset device commands or bits of code, chunks of code to the attached device running MicroPython. Because that device has the capability you need, like it has the LED attached, it has the temperature sensor. So this was a fun thing that came along. When did this get published? In October, 3 months ago. So so sort of August, September time. And again, I think it shows the richness and the ability to interact between different bits of the Python ecosystem. But you might be able to do the data science piece on the desktop because you've got the full processing capability and the ability to bring in all of the big libraries that have more complexity and more dependencies, whilst
Mm-hmm.
still taking advantage of the embedded hardware and belaying or asking that to do the bit that it's good at.
Mm-hmm.
So I think
Mm-hmm.
that's very
That
important.
is like rock climbing then. The belaying is there's a whole ritual, at least in the rock gyms that I've been to, where uh the person who's climbing will ask the person who is at the other end of the rope, and there's this, whole you're checking your knots and all of this stuff, and
Oh,
you on belay, and then the person who is belaying them says belay is on, climbing, climb on.
maybe that's
The
where that came from in
ceremonial.
that case. I was thinking of it in a naval sense, but maybe that's
That
how.
was
Yeah,
probably the original.
maybe. Yeah, absolutely. How interesting. How interesting.
Mhm.
I'm not too much of an outdoor sports person, so that, or even indoor with climbing
I'm
walls. But
only an indoor
yeah,
rock climber.
yeah, of course. Um, I have terrible upper body strength myself, but yeah,
So that's a secret, is that in the gym that I grew up in, one of the owner's daughters made a route that you couldn't rely upon your upper body strength at all.
okay,
And men rock climbers got very angry. This was not playing to their strengths,
okay.
because women tend to have more lower body strength.
Ah,
And so women were beating them at this route, and
what a
that
shame.
was unacceptable. And so, in fact, you do not have to have excellent upper body strength to be a rock
Interesting.
climber.
Interesting.
Um, it's
You've got to have really good,
climbing routes like that are, in fact, sexist.
and you've got to have great problem solving skills as well as a climber.
Hmm. Hmm.
So fascinating. Maybe I should
Yep.
pay more attention to that as an activity.
Yeah.
Wow. Wow.
Apropos of belay, I suppose. A bit of a tangent. But yeah, well, I this has just been a wonderful tour, and I am going to check out these communities and learn more about it. Thank you so much
Thank
for
you so much.
joining me and for imparting all of your wisdom.
You are so welcome. It's been an absolute pleasure and a delight. And
Yes,
I'm so
likewise.
sorry. I feel like I should have prepared better. I prepared all this other stuff over here to show you, but then I didn't prepare my web browser to share the screen on my computer, share the screen with you. So
Well, I would love to do this again if you would be up for it sometime.
so that would be on a future episode of
Laura's loquacious live stream.
Laura's Loquacious live stream. I'm looking forward to seeing more of these. And yeah, absolutely. Maybe I'll come back again in future. Maybe
Yeah,
you
that
can
would be
teach me
wonderful.
all about WebAssembly and PyScript by then.
Ooh, gosh. Goals.
There we go. Exactly.
Hmm. All right. Thanks so much.
Thank you very much.
Bye.
See ya.